Hello everybody. Here in this session we are going to study horizontal projectile. Okay. Till now we have studied something called oblique projectile, a projectile which was thrown from the ground making an angle theta. Okay. So we studied this till now, and for this we wrote an equation for trajectory. What is that? Y is equal to tan theta into x minus gx square divided by 2u square cos square theta. This was the equation for trajectory. This was in the form of y is equal to ax minus bx square. Since this is the equation of parabola, we concluded that trajectory of a projectile is a parabola. Okay. Then we derived equation for time of maximum height. Time of maximum height is equal to u sin theta by g. Okay. Then we know that time of light is equal to 2 times time of maximum height. So time of light is equal to 2u sin theta by g. Then we derived equation for maximum height attained by a projectile. So that will be h is equal to u square sin square theta divided by 2g. Then we derived expression for range. Range of a projectile is equal to u square by g into sin 2 theta. What is sin 2 theta? Sin 2 theta means 2 sin theta cos theta. Then we saw that when theta is equal to 45 degree, range is maximum. Equation for maximum range is equal to u square by g. So based on these formulae, we also solved some of the problems. Okay. Now in today's class, we are going to learn about horizontal projectile. Horizontal projectile. Okay, horizontal projectile. What is this horizontal projectile? We'll see. Say I have considered some building. Say this is a building. This is a vertical building. Okay, this is a building. From the top of this building, from the top of this tower, okay, a ball is thrown in the horizontal direction with velocity u. A ball is thrown in the horizontal direction with velocity u. Okay. I am writing this vector symbol because u is a vector. Otherwise, it is not required. Okay, u. Now, initially, ball was thrown only along the horizontal. Initially, ball is going only along the horizontal. After some time, what happens? The ball slowly starts coming down. Then the ball will have one downward velocity and one horizontal velocity, or the ball starts moving vertically and horizontally simultaneously. Correct now? But initially, the ball was thrown horizontally. Therefore, initial horizontal component of velocity is equal to u itself. Okay. Initial velocity is equal to initial horizontal velocity because initial vertical velocity is 0 because initially the ball was thrown along the horizontal. Very important. Then what happens? Ball will go like this. Okay. It will hit the ground somewhere here. In between, if I consider a point, okay, the velocity is this. Say here the velocity is this. What is that velocity? We don't know. Or speed. Okay, what is the speed? We don't know. But what we know is horizontal component of velocity will not change. We know this. Because even in the oblique projectile, we found that force was acting only downwards. There is no force towards your right or in the horizontal direction. Therefore, horizontal acceleration is 0. Therefore, horizontal component of velocity of a projectile is constant. Remember. So, therefore, horizontal component of velocity is constant. This is Vx. That is equal to Ux is equal to U. Very, very important. In the horizontal direction, velocity is not changing. Even after some time. Okay. But initially, vertical velocity is 0. But here, there is some vertical velocity. I call it as Vy. Okay. So, horizontal velocity is not changing. Final horizontal velocity, Vx, is equal to initial horizontal velocity, Ux, is equal to initial velocity, U. Okay. Now, what is Vy? Vy can be found like this. Vy is equal to Uy plus Ay into t. Correct now? So what is Uy? Uy equal to 0. Okay, Uy equal to 0. So what happens? Vy is equal to what is Ay? acceleration along y direction is minus g. Vy equal to minus g into t. Okay. Now what happens? Okay, Vy. Now what is the resultant velocity? Resultant velocity, see, you can use Pythagoras theorem here, correct na? So this hypotenuse square is equal to, okay, v square is equal to vx square, okay, plus vy square, What happens? V square equal to vx means u square plus vy. What is vy? Vy means minus gt whole square means what? G square t square, correct now? V square equal to u square plus g square t square, or v is equal to square root of u square plus g square t square. Using this equation you can find the velocity of the projectile at any point using the equation square root of u square plus g square t square. Now here this velocity, resultant velocity, is making an angle beta with the horizontal. How to define that angle? I'll define like this: tan beta, okay, tan beta equal to opposite side by adjacent side. What is this opposite side? Means Vy, correct na? Vy by Vx, correct na? Vy divided by Vx. So what happens? Tan beta is equal to, Vy means minus gt. You can ignore that minus because that minus symbol indicates that the body is coming down. Okay, gt. Vx means u, or beta is equal to tan inverse of gt divided by u. So using this equation, you can find the angle made by the velocity vector with the horizontal at any point. Using this equation, you can find the velocity of the projectile at any point. Okay, now we will find out the equation for time of flight, or we'll find the equation for time of flight, or time required by the ball to reach the ground, time required by the ball to reach the ground. We'll find out this. Okay, when the ball reaches the ground, what becomes zero? Y becomes zero, correct? Or y becomes equal to h. Say height of the building equal to h. Okay. Now, when the ball reaches the ground, vertical distance traveled will be h. Okay, I'll be using the equation y is equal to uy into t plus half ay into t square. So what happens? The ball is coming down, correct now? When the ball is coming down, we have studied sign convention, displacement is minus, okay? I'll write minus h equal to, what is uy? We know uy is equal to 0. Initially the ball was thrown along the horizontal, so 0 plus half into, what is ay? Ay is minus g into t square. Now, when the vertical displacement is h, this t is time of flight, correct now? Means it is the time required for the ball to reach the ground. So what happens? Minus h is equal to minus half g into time of flight whole square. So this minus gets cancelled, it becomes plus. So we get time of flight whole square is equal to 2h by g, or this implies time of flight is equal to square root of 2h by g, or time required by the ball to reach the ground is 2h by g. See, here there is one very important point. Okay, very important point. What is that important point? Say for example, there is a ball. Okay, this ball is dropped from a height h. This ball is simply dropped. Okay, simply dropped like this from a height h. What is the time required for the ball to reach the ground? We will calculate. How to calculate? X is equal to ut plus half at square. Correct now? The ball is going down. Distance traveled is minus. So minus h, correct now? Minus h equal to initial velocity is 0, correct now? Plus half a means minus g, acceleration is always minus, into t square, correct now? What happens? Minus becomes plus 2h by g. Here also, what do we get? Time required for the ball to reach the ground is equal to 2h by g. This is very, very important. What is important? If you simply drop a ball, then also time required is square root of 2h by g. If you throw the ball along the horizontal, in this diagram, if you throw the ball along the horizontal, okay, then also we found that time taken for the ball to reach the ground is square root of 2h by g. Means you can do this experiment, okay. You take two balls or two stones. First stone you drop it, okay, you keep it and you drop it, okay. Simultaneously you throw the second stone in the horizontal direction, okay. What you have to do? This ball you have to drop, the second ball you have to throw along the horizontal. You do it immediately after watching the video. You see that both the stones will reach the ground simultaneously, okay. So this is the important concept. Or you can just pause the video and do the experiment. Get out of the house, take two stones. First stone you just drop it, second stone you throw horizontally simultaneously, okay. Yeah, so what should be the experiment that you are doing? First stone you drop it simultaneously, second stone you throw it horizontally. You see that both the stones will hit the ground simultaneously, okay. Next, so we have calculated time required for the ball to reach the ground, okay. Then what we will do? We will calculate the range, okay. What is range? Range is distance traveled by the ball. Here, horizontal distance traveled by the ball. What is horizontal distance traveled by the ball? We will calculate, okay. I'll erase this. Okay, range means horizontal component of velocity into time of flight, correct na? Okay, range. What is horizontal velocity? U into what is time of flight? Time of flight we have calculated. Time of flight is equal to square root of 2h by g, correct na? U into range is equal to u into square root of 2h by g. So here in horizontal projectile, okay, you have to remember four important points. One is velocity in the case of horizontal projectile. You are throwing a ball like this. Initial velocity is u. Velocity at any point, speed at any point is given by square root of vx square plus vy square, or that is equal to, we have calculated, it is equal to u square plus g square t square. Angle made by the velocity vector, okay, at any point beta is equal to tan inverse of vy by vx, or that is equal to tan inverse of gt divided by u. And time required for the ball to reach the ground, that is equal to square root of 2h by g, which we saw that, which is very, very exactly equal to, even if you drop the ball, this ball will take a time equal to square root of 2h by g, where what is h? H is the height of the tower. Then horizontal distance traveled by the ball, or the range of the projectile is equal to horizontal velocity into time of flight, u into square root of 2h by g. So these are the four important formulae that you have to remember as far as horizontal projectile is concerned, okay. Now we will solve two more problems, okay. Two problems. See, an aeroplane is moving horizontally with a speed of 180 km per hour, drops a food packet while flying at a height of 490 meter. The food packet was found at a horizontal distance x with respect to the drop point. Then x is, see, this is the aeroplane. Don't laugh at me. This is how I draw aeroplane. It is moving with a speed of 180 km per hour. 180 km per hour. It drops a food packet. When it drops a food packet, initially it had a velocity. It had a horizontal velocity 180 km per hour. It will not directly fall like this. It will fall like this. Correct na? Okay, from a height, what is the height? From a height 490 meter. Okay, the food packet was found at a horizontal distance x with respect to the drop point. This is x. What is the value of x? You have to find out x. Okay, what is the value of x? X means horizontal range. Horizontal range equal to initial velocity into time of flight. What is the formula? 2h by g. Initial velocity u is given, h is given. Correct now? But u initial velocity is given in kilometer per hour. Initial velocity is given in kilometer per hour. So how to convert 1 kilometer per hour? 1 kilometer per hour in meter per second. 1 kilometer per hour in terms of meter per second. 1 kilo means 1000. Correct now? 1000. Okay, 1000 meter, okay, divided by hour. Per hour means divided by hour. In 1 hour, how many seconds? 3600 seconds are there in 1 hour. 1 minute 60 seconds. So for 1 hour 60 minutes, 60 into 60, 3600. So what happens? So these two zeros and zeros again get cancelled. Okay, 2 goes 5 times, 2 goes 18 times. 5 by 18 meter per second. Okay, 1 kilometer per hour means 5 by 18 meter per second. So how to convert kilometer per hour into meter per second? By multiplying by 5 by 18. Okay, what we will do? 180 kilometer per hour means I'll do the calculation somewhere here. Okay, 180 kilometer per hour means 180 into 5 by 18 meter per second. 180 into 5 by 18 meter per second. 18 goes 10 times, 10 into 5, 50 meter per second. So while calculations always use SI units. SI unit for velocity is meter per second. If the data is given in kilometer per hour, you have to convert that into meter per second. Very, very important. Keep it in mind. So u is 50 meter per second into square root of 2h by g. 2 into h, 490. G is 9.8. G sometimes we can take it as 10, correct? Now, but why I have taken 9.8? 2 into 490 is 980. 2 into 490 is 980. 980 by 9.8 is 100. Square root of 100 is 10. 10 into 50 is 500 meter. So the value of x is 500 meter. Okay, it's a typical problem. Try to understand. Okay, next, a very simple one. A projectile. So this is a problem related to oblique projectile. Okay, a projectile is projected with kinetic energy k. Okay, if it has the maximum possible horizontal range, then its kinetic energy at the highest point. Okay, if it has the maximum possible horizontal range, means what is given? They have given a hint. Theta equal to 45 degree. Correct na? Theta equal to 45 degree. Theta equal to 45 degree. Theta equal to 45 degree. This is the projectile. Kinetic, if it has the maximum, okay, a projectile is projected with kinetic energy k. Okay, initially here the kinetic energy was k. Okay, what is the question? Then its kinetic energy at the highest point. What is the kinetic energy here? Okay, what is the kinetic energy at the highest point? kh. Okay, that you have to find out. Okay. So initially, what is kinetic energy? Kinetic energy equal to half m into u square. Let us suppose that projectile is fired with velocity u. Okay, at the highest point, what will be the velocity? See, initially, if the velocity is u, horizontal velocity is u cos theta, correct na? What is vertical velocity? Vertical velocity is u sin theta. Very important, listen, correct na? If the initial velocity is u, horizontal velocity is u cos theta, vertical velocity is u sin theta. At the highest point, vertical velocity is 0, correct na? Vertical velocity is 0 at the highest point. So at the highest point, the velocity is only u cos theta. Therefore, what is the kinetic energy at the highest point? Kinetic energy at the highest point equal to half m into u cos theta whole square. Half m into u cos theta whole square. Or kinetic energy at the highest point is equal to half mu square into cos square theta. Half mu square into cos square theta. Okay, what is cos square theta? What is theta? Theta is equal to 45 degree. Theta equal to 45 degree. Cos 45 degree is equal to 1 by root 2. Cos square theta. Cos square 45 degree means 1 by root 2 multiplied by 1 by root 2 is equal to 1 by 2. So what happens? Half mu square. What is half mu square? Half mu square means k. So k into 1 by 2. K into 1 by 2. 1 by 2 means 0.5, correct na? 1 by 2 means 0.5. So kinetic energy at the highest point is equal to 0.5 k, 0.5 k. Okay, hope you understood this. Okay, or else just come back. Okay, rewind for 3 minutes and listen once again. This is also a typical problem. Okay, next, very simple. This I have discussed already. A ball P is thrown horizontally from the top of a tower, and another ball Q is just dropped simultaneously. The ball that reaches the ground first is, both P and Q will reach the ground together. I told you have to do the experiment. Why they will reach together? Okay, why they will reach together is because, okay, motion in one dimension is independent of motion in another dimension. Motion in one dimension is independent of motion in another dimension. If the ball has to hit the ground, okay, so its vertical displacement is very important. Correct now? Vertical displacement depends on vertical velocity. If you throw the ball in the horizontal direction, and here you just dropped the ball. Correct now? Huh? So if you throw the ball in the horizontal direction, what is its initial vertical velocity? Initial vertical velocity is 0. Here also initial vertical velocity is 0. Okay, then vertical velocities will increase at the same rate in both the cases. But what about initial velocity given in the horizontal? Because of that, ball is moving forward. Okay, due to horizontal velocity, ball moves forward. But both the balls had initial vertical velocity equal to 0. Therefore, both the balls travel equal vertical distance in equal time. Okay, therefore, both P and Q will reach the ground together. Okay, hope you understood this lecture. Thank you very much.